We're very grateful that it worked. We're thankful for all the support we got, and you guys included. Thanks so much.
Ravi, you have quite an interesting title there: Entry, Descent, and Landing Engineer. Are you part of all the stages of the Curiosity mission?
The group that I'm in, the Entry, Descent, and Landing group, we're in charge from the moment that we start to enter the Martian atmosphere until we touch down on the ground, and actually even a little bit before that. So there's a team that's in charge of the cruise phase, which is the part where we're getting to Mars, when we're in space, and then when they're done, my team takes over and we help them land on the ground.
That is great, absolutely great. We have a word here when actually it's also in your country. When we get in trouble or see an impossible situation, hard to accomplish goal, it's rocket science. Did the Curiosity mission was rocket science also? It was so hard.
It was rocket science and brain surgery combined.
We have some questions. We have interesting questions from the public. Okay, I have a girl here. Can you come in front? Come in front because Ravi needs to hear you. We don't know the question actually, Ravi. It's a surprise for us.
Hello, I'm Daria, and I want to ask you something. What's the date when you launch Curiosity from the Earth?
Can you repeat the question, please?
What's the date when you launch Curiosity?
Launched Curiosity, I think it was November 28th last year. It was 2 days after a holiday, Thanksgiving. But it was late November. It takes 8.5 months to get to Mars. During that time, we're traveling over 8 miles an hour. Maybe call that about 13,000 kilometers per hour in space. And it takes us 8.5 months to get to Mars because it's that far away.
And I was asking that because if Earth is close to the Sun on the 3 January, you could did you use this date to get like the amount of combustible use a fuel? Yeah.
We picked the date and the arrival date such that we would have to use amount of fuel in space from Earth on the launch rocket. It turns out the further the spacecraft has to travel to Mars along its trajectory, the less fuel it needs. Because let's say Earth and Mars are very, you have to fight a lot more of the sun's gravity. They're further away on opposite sides of the sun. It's the least amount of fuel. The sun's gravity to help pull it around.
Thank you very much for answering my question.
Okay. I hope I answered it.
Actually, she is part of is part of an astronomy group. It was a bit of a question. Okay. Maybe you can answer her to the email because some interesting technical question. Maybe help in your position. You can help young people understand some part of the missions.
Absolutely.
Yeah. That will be great.
Get my email out. I will happily answer questions.
Thank you for that.
You know what? The landing of Curiosity on Mars yesterday. You know, we have some big telescopes here, but our it's not possible because it was clouds.
Clouds. We couldn't see the landing because we're clouds on. We saw the picture from going around the Mars.
Yeah, so a lot of people expected to see the spacecraft as it was landing on Mars. Remember that would show the spacecraft landing on Mars. There would have to be something there before. So we have orbiters that orbit Mars, and they've been there for many, many years. One of them took a as we were going down. So we had a great picture of the spacecraft with the parachute deployed that I can send to you guys. Also, we use those spacecraft to tell us what the craft that we were landing, called Curiosity, and so the rover sends out information to orbiters, and these orbiters send information back. That's how we give us the information about what the spacecraft did.
Okay. For you, why Australia is the first country from rover from Curiosity?
Your question was which one received the signal?
Yeah, I understand that Australia is the first country who received the message. It's mainly you have a big antenna.
Exactly. We have around the world 3 antenna dishes that are 70. That's about the size larger than a, let's say, 15.
Whoa.
And yeah, and the dish was able to see the spacecraft when it is located in Australia, in Kansas specifically. And so that received the signal, then the signal went to California, which is where JPL is, laboratory, and then we saw it from there.
Ravi, we were wondering what's so special about the Gale crater, the place where the Curiosity rover landed. What can you tell us about that?
What's really special about it is that because it's a crater, it's like seeing below the surface of Mars. It's like someone already took a shovel and dug out Mars for us. And because of that, you can see what has happened on Mars. Looking back 2 billion years to when Mars was almost formed, or after Mars was formed, into the layers that have happened. So by driving the crater and analyzing the rock, we can see the history.
Thank you so much.
Too fast.
No. Everybody understands you. The stages of interest in the atmospheres of the landing, I can't stop wondering what if something happened. You know, there were so many where something wrong happens. So look at this, all this mission, and you actually did a really great job here. So we owe you many thanks for that.
Yeah, we called the entry descent landing on Mars the minute of terror because it takes 7 minutes to go from 21,000 kilometers per hour, which is more than 5 times as fast as a bullet, all the way down to the ground. Thousands of things have to happen right. For example, we have to deploy our parachute, which is the largest parachute ever built. This parachute is 7 stories tall. It gets deployed supersonically, which means faster than the speed of sound. It slows us down to about 250 kilometers per hour, and then we fire rockets. These rockets have to make sure that the spacecraft stays upright, and the rover is attached to like this rocket backpack, and the rockets fire, and eventually it releases the rover on this cable. And then they both continue to fall down, to go down slowly until the rover touches down. Then it cuts off this backpack, and the backpack flies away, and then the rover's ready to go.
Well, thank you for the answers. We have here, besides young people, a lot of special guests. So
You're right.
So I will give the microphone to one of them, just to put your question.
You have the camera over there, so we can watch.
My name is Ed, and I'm really curious about what it was to be part of a team whose mission took so long, yet had such an important vision, and what you went through in terms of your energy and how that vision supported you, and the challenges and the good news, bad news, all of that during that.
Great question. So I have been on this project for over 5 years. There are people that have been on this project for over 10 years. This project was first conceived about 10 years ago, and there are people that have been on this project for time. There have been many problems that we have had to solve. For example, our parachute had many failures during testing. Our heat shield, which protects us from the atmosphere, that we had to do because we realized the material we were going to use wasn't going to work. And so all these things cause all this to come together very quickly. I've had this privilege of working with what I think is the smartest engineers in the world that have put this rover on Mars. And I feel grateful and blessed that I've been able to work with this group. And it's not out of reach for anyone to be able to come to NASA, to work at NASA, to work on anything that you want to. A lot of people don't believe when I tell them that I'm actually not smart. I'm a very hard worker, and that's, I think, what counts for succeeding in life in general.
Well, after all this hard work, you did it, and you did it well. We were just the last question or last moments of our video conference. When we talk on email, we talk with you on Martian time, and we were puzzled in the beginning. What is Martian time? What is GMT to connect to our hour? So can you please explain to us?
Maybe it's better for us to switch at the same time.
So, as you probably know, a day on Earth is 24 hours. And that's because it takes the Earth 24 hours to turn all the way around on it.
Yes.
So wherever you're now, in 24 hours, the Earth will be facing that same direction from the Sun in 24 hours. Mars turns a little slower than Earth. So it takes 24 hours and 40 minutes for it to turn around on its axis once. So a day on Mars is 24 hours, 40 minutes.
Oh.
And because of this, the scientists who are working this mission, every day they have to shift their schedule by 40 minutes. And that helps them to, every day in the morning, they can come and say, okay, the rover is at this position relative to the Sun. So let's say we landed when it was about 3 p.m. on Mars. That means that the Sun was in the same place that you would see it at about 3 p.m. And we want to do that consistently, at least for a few months. So that are working this mission have to shift it 40 minutes every day, and that can be a little tiresome at points.
Now we are enlightened by the sun and not by you.
Yeah. Another curiosity from my side. Is any connection between the video games and the driving of NASA Curiosity Mars rover?
Are you talking about video games that we produced for this mission?
Any connection with any, help?
What's interesting is that NASA partnered with Microsoft, which is a computer company. They partnered with Microsoft to produce a video game where you get to see what it's like to land a spacecraft. And so you get to move like the spacecraft would, and your job is to keep the spacecraft for its landing on Mars.
A kind of training software? A training software, I think, right?
Yes.
Okay.
Last question from the public. Was Bogdan somewhere?
Yugi?
Yugi? From Africa. We have also special guests.
No, it's not. They're from United States.
Hello. Okay. Yes, this is a very special moment for all of us here. And actually, the question I'd like to ask is about all these young kids who are here today, watching you on this special occasion. I want you to tell us, I know you say that you are a hard worker, and that counts for most of the things. I want you to send a message to all the youngsters out here that they could do what you are doing right now, because I think that will be the most important thing that they will take with them tonight. Please tell us. I want you to enlighten them and tell them that you were born in a different country, you went there, you are doing this, so anyone else could do that. Thank you very much for a hard work.
Thank you. That's a great question, Yugi, and great comment. I think that it is very important to dream big. If you have to dream bigger than you think you can get to, because that's how you accomplish anything. Dream so big that you can never accomplish it in one lifetime is a saying that I've heard before. Make sure to realize that to get to those dreams that you have made that are too big to reach, that you have to continue to work hard every day of your life, and make sure to surround yourself by the best. Going to this camp, for example, is a good step in reaching your dreams, because you're surrounding yourself by the best and the brightest that you have to offer, and that's fantastic. Learning from Gabby and all these people that know so much is a fantastic thing to do. And I think continue to go to camps like this, continue to learn, because education is key. Education is what will lift you out of any circumstance that you're in. I've been to India several times, and I stress there that to get out of poverty, which a lot of those people are in, education is the answer. That is what will help you go to college, get a degree, get a great job, and be able to support your family and help others. Always continue to mentor people that are younger than you, because that's how they will achieve the same thing that you have achieved.
Thank you. Ravi, we don't have words to express the thanks and the honor that you give to us to be in contact with us, and also that you accepted to also be tomorrow with our astronaut. Okay, so we'll meet Ravi tomorrow also. If you have any questions for him, please think about it. And also we thank you on this occasion to World Genesis Foundation, who make this contact possible. And of course, we have no words to thank, but we have our excitement. So thank you again.
Thank you.
Ravi Pruchet, entry, descent and landing engineer from NASA JPL. Thank you, Ravi. See you tomorrow night.
Hey, thank you for having me. I appreciate it.
Profesor,